Hi, I'm Dee. Welcome to Maths with Dee, where we break down maths step by step. Today we're going to learn how to simplify algebraic expressions. So let's get started. So today's learning goal is listed here on the slide, and we are going to learn how to simplify algebraic expressions by collecting like terms. There's a little to unpack over here, so before we actually get started, we're going to learn what an algebraic expression is and also its different constituents. So if you have a look at the 4x plus 12y minus 3, this is what we call an expression. It can be called an equation if we were to write an equal sign, and this could be equal to anything, but I'm just going to write 0 for simplicity. So the second you see that equal sign again, it tells you that we have an equation. With our expression, we have several components, and the easiest way to determine these components is if you were to ignore any plus or minus signs. So when we do that, you'll see that we get 4x, which is one term, a 12y, which is the second term, and over here we have a minus 3, which is our last term. So all of these things are called terms. But even though I said that you don't want to include your plus or minus signs, they actually get taken account of as well. When you are looking at those terms, you need to include those signs. Let's continue on. We have some letters over here. And in this expression, we have an x and a y. These two, they are called pronumerals, or they are also called variables depending where you're from. So the reason why they are also known as variables is because the value that they represent changes, so it varies, and that's why variable is also a suitable name. Now, when you also look at the numbers here, we have two important numbers that we are going to deal with, and they are the number in front of our letters, our pronumerals. And these two numbers, these are called coefficients. So just the number in front of the letter is called the coefficient. And finally, we actually have another number which I did not highlight, and that's because if you have a number by itself, it's called a constant, or you can also know it as a constant term. And again, it's a term because it's a single item by itself within this expression. And we also said that the whole thing, without the equal sign, that is called an equation. Okay, so now that we've dealt with our algebraic expression, let's talk about what like terms are. So like terms are basically terms that contain the same pronumeral. So if you look at our expression, we have the 4x plus 12y minus 3. I could conjure up a like term for my minus 3 if I were to just write down a number. So any number that I want, it could be 7, 8, it could even be negative 100. These are all like terms to our 3 or our minus 3. If I am talking about my 4x, well, as long as I write down x's and then put any number in front of my x, I have these like terms as well. Okay, and so for my y term, my 12y, if I were to just change up my coefficient, then I also have like terms here. And I notice that I just keep writing the same number, so I'm going to add another digit there. Okay, now that that's sorted, we are going to go through the examples. We have 10 of them here, and the intention is to just simplify the following algebraic expressions by collecting like terms. So let's see how this comes about. All right, so here are our 10 questions, and the first thing we are going to do every single time is just identify the pronumeral in our question. Okay? So in the first question, if the pronumeral is x, I am going to write x down in my answer. And once I have dealt with my pronumerals, I'm going to start looking at the numbers in front of them, my coefficients. And I see that all I need to calculate is 3 plus 5, and that gives us 8. And so our first answer is 8x. When we do the second question, the exact same concept, the exact same steps, despite there being a minus sign. Okay, so now I see that my pronumeral is a g, so I'll write the g down. And now I just have to deal with my coefficients. We have a 9 minus 2. And so I'm going to write a 7 in front of my g, and there is the answer. Okay. For question 3, I will start identifying my pronumerals, and it is an m. And you might notice that for this question, we actually do not have a coefficient in front of them. Okay. Whenever the coefficient is missing in front, it just means that there is a coefficient of 1. So we can add that back in to see that our answer is a 2. All right. So let's do question 4 now. We are going to identify our pronumeral, which is an s. And so the answer will have an s. Looking at our coefficients, we have 8 plus 2 minus 9, and that is going to give you a value of 1. And just like question 3, we can actually rewrite this to remove the coefficient. You can omit it because it's not really necessary in your final answer. Okay, so our final answer is just an s because, again, that 1 can be omitted out. Okay, for question number 5, same step. Our pronumeral is an f, so I'm going to start off with my f. And 7 minus 7 for our coefficients, well, that is just 0. So I'm going to write a 0. But just like the previous question, this can be further simplified. And what 0f means basically is 0 times f. And 0 times anything is just 0. So we do not have to write the pronumeral anymore. All right, the answer is just 0. Question number 6. Scanning across my pronumeral is a y. I'm going to write my y down. Okay. Looking at my coefficients, I see that 5 plus 3 is 8, so the answer is 8y. Now for this question, I'm actually not done because there was one term that I hadn't touched yet, and that term was the minus 4. Okay, so I actually need to write down minus 4 at the back because I did not combine it. I did not treat it as a like term, so it's still present in the final answer. Okay. Question number 7. Let's scan across looking for our like terms. I see that there is an a here, and that's actually the only a, so I am going to immediately write down for a. When I scan across again for other pronumerals, I see that there is also a b. So I am going to write a b in my answer, and I'll deal with the coefficients for my b's to see what they combine to. Okay, so what I'm adding together is a plus 6 plus 9, and I am going to write 15. Okay, however, if you recall back to when I first explained expression, and if you even look at question number 6 or all the other questions, we always had a sign connecting each term. So it looks really incomplete when I have 4a, 15b. I need to determine whether I put a plus or minus sign here. And to do that, I just look at the coefficients that I was adding. If I am doing 6 plus 9, that's a positive 15. So I'm just going to put a plus sign in between my 4a and my 15b. I'm not done yet though. I still have some constant terms that I need to deal with. And in this case, I actually have 2. I have a minus 2 plus 8. And so I will combine these like terms together to get a single answer. And that is going to be a positive 6. There you go. All right. Next question, exactly the same setup. Okay, I'm going to scan across and I'm going to see if I have any like terms. I have an A over here, and even though I have an AB and a BA, which both contain an A, I'm going to skip this out because they're actually not like terms. Okay, I need to have the exact same letter for it to be a like term. So just like before then, that means that I'm going to write my 2A by itself. And I'll continue my search for other like terms. When I do my next one, I see that I have a B term here and a B term there. So that means I'm going to pop a B down into my answer. And now let's deal with the coefficient of my B terms. And it says minus 6 minus 3, which is a minus 9. And finally, I have an AB and a BA. And I've actually highlighted them both because they contain the exact same letter. So they are like terms despite the order not being there. All right. We like writing our pronumerals in alphabetical order, but examiners like to confuse us by kind of swapping the order around and making us question ourselves. But if you see the exact same letter, regardless of the order, they are like terms. So that means I am also going to write my AB in my answer. Okay, let's determine the value of the coefficient. We have a 9 plus 8, and that is a positive 17. All right. Question number 9. Over here, scanning across, you might notice that our pronumeral, or our like terms in this case, they are our x, y. I'm going to write my x, y down, and I'll determine the value for my coefficient. Minus 12 plus 7, well, that is minus 5. Okay, and you'll see that this 4 is left untouched. I'm going to add it at the back, but again, it looks really weird and incomplete if I do not have a sign connecting the negative 5xy with this 4. And anytime in maths you see a number by itself, no signage, okay, it's always a plus sign. If you do see this question in a textbook or something similar, textbooks might have a different answer, okay? And what they'll do is they will just rewrite this so that your first term is not a negative term. And that means that we leave the 4 at the front and we attach that negative 5xy to the 4 instead. Okay. When we do our last question, I want to start off by finding out my like term. And over here, it kind of seems like all 3 of them are like terms. But if you look closely, you'll see that the first term is x squared y, the next term is an xy squared, and the last term is an x squared y. So if I'm being very critical, only the last or the first and the last terms are like terms. And that is because that squared, or that little power above that x, tells you how many times we see an x. So x squared y really means there are 2 x's and 1 y. But for our y, or xy squared, it means that we have 1 x and 2 y's. So what I'll do is I'll first write down my x squared y, and I'll determine the coefficient. Okay, so 8 minus 6, well, that's 2. And we will have to leave the negative 3 xy squared exactly the same. Nothing can be done to it because it's not a like term. And there you have it. That's how you find, or that's how you simplify algebraic expressions by collecting like terms. So before we conclude this video, there are some key tips I want to share with you, and they are down here. So the first is you need to make sure that you are only focusing on the terms with the same pronumeral, and that just means that they are like terms. The next is watch out for your positive and negative signs, okay? Not just when you're trying to answer the question of, let's say, minus 12 plus 7, but also whether you put a plus sign or a minus sign in between two terms. Okay? And finally, we treat constants as like terms with other constants. So make sure you don't combine them with pronumerals. So what I mean by that is, I don't want to see people writing, minus xy for assuming that you need to combine that minus 5xy with that 4. Okay? And that's the end of the video. So I hope that you found this helpful. Please give this video a thumbs up and subscribe for more clear step-by-step math lessons if you enjoyed it. And because this is my first video, I would appreciate it if you have any suggestions or tips or other thoughts about, the presentation of the video, the content, etc. Just leave it down in the comment section below. And yeah, thank you for your time.